So let's see an example of conjugate function. So for that we define fx x transpose qx. Let's make it half, where q is positive definite definite. So our f conjugate function f star y is gonna be supremum x element of dom f yt x minus half xt qx. All right. So now let's take a gradient of this portion. Ytx minus half of xt qx. So this gradient is going to be 0. And then we get, so the gradient for this portion is y, because the gradient is always a column vector. So y is already a column vector. So if we differentiate this one, we're going to get y, and y is a column vector. And minus, so the general form for this xt qx is q plus qt to x, and we have here q is, this is positive definite, and this is also symmetric. So we have q transpose is equal to q. That means this is gonna be twice q x. So this is gonna be twice qx equal to 0. So y minus qx equal to 0. So x equal q inverse y. Now this x is actually x star, which is corresponding to the optimal value. Next, we need to put this value into our equation. So y is equal to supremum of x element of dom f, and then y transpose x. Y transpose. So for x we put this q inverse y minus, so this is equation 1. So this is from where we are getting this thing. And now then we have this portion, So this is half, and xt means q inverse 1 y transpose q, then q inverse y. Now what is this portion? This portion is basically half y transpose q inverse. So basically this thing is q inverse. If we take transpose of this, we should get this. So that's how we have this y transpose q inverse when we do the transpose of this, we are getting this. And q inverse, if we transpose q inverse, we are gonna get q inverse as well. And then the next part is gonna be q as it is, and then q inverse y. Let's put it somewhere. Somewhere here, so that we can keep writing. So this thing basically means half of yt q inverse of y. Therefore our f prime of y is equal to supremum of x element of dom f, and this one we need to subtract this one with this one from this one, and then we actually get half of y transpose q inverse y. So this is our equation. Now here it's a really interesting thing from this example. If we just remove everything, and put this thing back to here, then we can see these things side by side. So if fx is equal to is this, fy is gonna be this. The conjugate function is gonna be this. So what does it mean? So say so if q is, let's start with this one, fx equal half of xt qx. So what does it mean? If q is an identity matrix, then fx equal to half xt x, which is a circle. Now if q is not an identity matrix, then fx is actually an ellipsoid. And it's important to know that what is the function of q here. Q is, so here if this is a circle like this, when q is we are considering that q is not an identity matrix, it's gonna stretch it. And then we're gonna get something like this, an ellipsoid, and this is gonna be in the direction of q. So that is what the physical meaning of this this function. But what does this conjugate function mean? So this looks pretty much similar. So let's just see this portion, yt q inverse y. So it means that q inverse is taking place instead of q. q inverse is taking place instead of q. So that means here we can also consider a circle like the other one. If q is equal to 1, if q is equal to identity again, then q inverse is also identity, and then we can say that this is a circle again. But what if q is not an identity? Then q inverse is gonna be also creating an ellipsoid, but the ellipsoid is gonna be different from the previous one, which is this. It's gonna be different from this one. So for this one, say if the value of q is more, then the stretching is gonna be more, and at the same time if we take inverse, it's gonna be actually contract. So basically here with this function we can see that we are gonna get an ellipsoid, but this is gonna be more q is gonna be working more as a contracting role rather than stretching, that is being done for the previous function fx.